Welcome to another Knowledge Nugget. Today's topic is one that every IT person has thought about at least once. Imagine your company's server crashes, your VM is gone, your data is gone. What do you do? 20 years ago, the answer meant digging out backup tapes or external drives, or finding that backup server sitting in a closet somewhere. You'd rotate media, label boxes, and hope nothing went wrong. And here's the thing, you only knew your backup worked when you actually tried to restore it. Azure Backup changes that equation. No tapes, no on-prem servers, no crossed fingers. By the end of this episode, you'll understand exactly what Azure Backup is, what it protects, and how it works behind the scenes. Let's start with the simplest definition. What Azure Backup actually is. Azure Backup is Microsoft's built-in backup service for the cloud. But that simple answer hides something bigger. It's not a single tool at all. It's a connected platform that protects virtual machines, databases, file shares, and even machines sitting in your own office. Instead of managing backup hardware and software yourself, Azure handles the storage, the scheduling, and the security. You tell it what to protect and how often, and it does the rest. Think of it like a safety deposit box at a bank. You drop your valuables in, and the bank handles the security, the fireproofing, the vault. When you need something back, you go get it. You don't build your own vault in your basement. Azure Backup works the same way. You don't buy backup servers or manage tape rotations. You just decide what matters and let Azure store it safely. That's the real difference from traditional backup. No more tape rotations or offsite storage management or fingers crossed, hoping it works when you need it. Behind the scenes, Azure Backup uses something called an agent for most workloads. It's a small piece of software that installs on your machines, whether they're in Azure or sitting in your office. That agent coordinates the backup process, telling Azure when to take a snapshot, what data has changed, and where to send the copy. Now, here's the thing. You don't have to install anything manually for Azure virtual machines. When you enable backup on a VM through the portal, Azure installs that extension automatically. One click and it's done. Azure Backup is really a managed service. You define the policy, it handles the execution. No backup server to patch, no storage array to expand, and no wondering if your weekend full backup actually ran. But what exactly can you back up? That's what we'll look at next. What Azure Backup protects. So what can you actually back up with Azure Backup? Let's go through the main workloads. Azure VMs are the most common use case by far. You enable backup on a virtual machine and Azure takes a full copy of it, including the operating system, the applications, and the data disks. If that VM gets corrupted or accidentally deleted, you can restore the entire thing from your backup, and that's the safety net for your compute workloads. VMs are just the start, though. What about the databases running inside those VMs? SQL Server and SAP HANA aren't just files on a disk. They have complex structures, transaction logs, and specific recovery requirements. And Azure Backup understands that. When you back up a SQL Server database running in an Azure VM, Azure Backup coordinates with SQL to make sure the backup is application consistent. That means when you restore, the database comes back clean, with no corruption, no missing transactions, and no surprises. You can even set recovery point objectives as low as 15 minutes for your most critical databases. Here's something a lot of people don't realize. Azure Backup isn't just for things running inside Azure. It can also back up on-premises servers, physical machines, VMware virtual machines. You send their backups directly to Azure using the Microsoft Azure Backup Server or the Mars agent. That means you can retire your tape library and use Azure as your offsite storage with no more shipping hard drives to a vault somewhere. Azure file shares are another workload. Think of them as cloud-based shared folders, the kind your team uses to collaborate on documents. Azure Backup protects those file shares, so if someone accidentally deletes a folder or a ransomware attack encrypts your files, you can roll back to a clean version. Azure blobs cover your unstructured data. Images, logs, backups of other systems. Azure Backup can protect your blob containers too. And then there are Azure disks. Sometimes you don't need to back up the entire VM. Maybe you just need to protect a specific data disk. Azure Backup supports that as well. Here's a real-world scenario. Imagine a company running their infrastructure in Azure with a few production VMs, SQL Server databases for their line of business applications, and an old file server still sitting in their office that they haven't migrated yet. With Azure Backup, they protect all of it from one vault. The VMs, the databases, the on-prem file server, one backup strategy, one place to manage it, one set of policies. That's the power of a unified platform. So Azure Backup supports a lot. But the real question is, how does it actually work? Let's find out how backup actually works. The two-phase process. When a backup triggers, two things happen. And understanding this distinction is the key to knowing why Azure Backup is both fast and safe. Phase 1 is the snapshot. Azure takes a point-in-time, read-only copy of your data. For a virtual machine, that means it captures the state of the disks at that exact moment. This happens quickly because it's a snapshot. It's not copying every byte of data yet. Think of it more like taking a photograph. The snapshot is stored locally, right alongside your VM, so it's available for fast recovery. Phase 2 is the transfer to the vault. That snapshot data gets moved to your recovery services vault or backup vault for long-term storage. This takes longer because the data is actually being copied and transferred, but it gives you that offsite safety. If your entire Azure region goes down, your backup data is safe inside the vault. This two-phase approach makes instant restore possible. Because the snapshot is stored locally, you can restore a VM from the last few days' worth of snapshots almost immediately, without waiting for data to come back from the vault. For older recovery points that have already been moved to the vault, the restore takes longer, but the data is still there. After the first backup, things get even more efficient. Azure Backup uses incremental backups. After the initial full backup, only the changes get sent, not the entire VM each time. If you change a few files, only those change blocks are transferred, which saves both time and storage space. Policies control everything. You define the frequency like daily, hourly, or weekly. You define the retention like how many days, weeks, months, or years to keep each recovery point. And you define when to move older backups to colder, cheaper storage. A typical policy might back up a VM once daily, keep the last 30 daily points, and move anything older than that to the archive tier, where it costs a fraction to store. Here's a concrete example. Say you have a production VM running a web application, and you set a policy that backs it up every night at 2 a.m. You keep 30 daily backups and also 12 monthly backups for compliance. After the first full backup, every subsequent backup only transfers the changes. If your VM has 100 GB of data but only changes 2 GB per day, each nightly backup is roughly 2 GB. That's efficient. Now you know the mechanics, but there's one thing that makes Azure Backup different from everything else: how secure it actually is. The security layer, why Azure Backup is hard to attack. Let's talk security, because this is where Azure Backup really stands apart from the old way of doing things. Every backup you create gets encrypted by default. At rest inside the vault, it uses AES 256-bit encryption. That's the industry standard. While data moves from your machine to the vault, it's protected with HTTPS and TLS 1.2 or higher. Even if someone grabbed the data stream, they couldn't read a thing. But that's just the starting point. Every backup tool does encryption. What makes Azure Backup different is what happens when someone tries to delete your backups. First, there's soft delete. If a backup gets deleted accidentally or on purpose, it doesn't vanish. It stays hidden inside the vault for 14 days. You can recover it. That gives you a chance to undo the damage before it becomes permanent. Think of it like a trash can with a recovery period. You still have the option to empty it, but you have to explicitly confirm that you want to. Then you have immutability, and this is a bigger deal. Once you set a retention period for a backup, that recovery point cannot be deleted early. Not by an administrator, not by someone who compromises an admin account, not even by Microsoft. The data stays until the retention period expires. Period. If your policy says keep daily backups for 30 days, every single one of those 30 recovery points is locked tight. An attacker could delete your production VMs, but they cannot touch the backup data. Now here's where it gets interesting. Azure Backup supports something called multi-user authorization, or MUA. Critical operations, like disabling soft delete or turning off immutability, require approval from two separate people. One person cannot compromise the backup, not even a global admin. You need two authorized users to agree before those security settings change. That's a serious defense against insider threats. For organizations with strict network rules, you can use private endpoints that routes all backup traffic through your Azure virtual network using private IP addresses. The data never touches the public internet. If your compliance team demands network isolation, this is how you get it. But here's the real evolution that most people don't know about. Azure Backup now integrates with Microsoft Defender for Cloud. That means your backup restore points can be scanned for malware before you restore them. Imagine a ransomware attack hits your company. Your production systems are encrypted. You plan to restore from backup. But what if the backup itself contains malware? That's the nightmare scenario. With this integration, Defender scans your restore points and flags any that show signs of infection. You can then choose a clean recovery point instead of restoring the problem. In a real ransomware attack, attackers almost always try to delete backups first. That's their playbook. Immutability stops that. MUA prevents a single compromised account from disabling protection. Soft delete gives you a recovery window. And Defender scanning ensures the data you restore is actually clean. So Azure Backup is secure. But how does it compare to the tools you might already be using? Azure Backup versus the alternatives. Let's talk about alternatives because you have options, and the right choice depends on your situation. Traditional on-premises backup is what most companies have done for decades. You buy a backup server, you buy storage, you buy backup software licenses, you manage tape rotations or disk arrays, you handle offsite storage yourself. The upfront cost is significant: servers, storage, software, and the people to run it. And you have to refresh that hardware every 3 to 5 years. The operational overhead adds up fast. Azure Backup flips that model. You pay a subscription. No hardware, no software to install on a backup server, no tapes. The cost is predictable and scales with what you actually protect. Then there are third-party tools like Veeam. Veeam is excellent at what it does. It supports complex environments, multi-cloud, hybrid, on-prem and cloud, advanced recovery scenarios. It offers features like instant VM recovery and deep ransomware defenses. If your environment is a mix of Azure, on-prem VMware, and even AWS, Veeam gives you a single platform to manage all of it. That's powerful. But there's a trade-off. Veeam is more expensive, especially at smaller scales. A small Azure VM with 50 gigabytes of disk costs about $10 a month with Azure Backup. The same protection with a third-party tool could be 2 to 3 times that. And you still need to manage the backup infrastructure, the Veeam server, the repositories, the proxies. So where does Azure Backup win? Simplicity and integration. It's built into Azure. You don't provision a backup server. You don't manage separate storage. You set policies from the Azure portal. It works with your existing Azure RBAC roles. It integrates with Azure Policy for Governance. For a pure Azure environment, it's the most cost-effective and simplest option. Where do third-party tools win? Complex environments. If you have workloads across multiple clouds or a significant on-prem footprint, a tool like Veeam justifies its cost by giving you unified management. And for organizations with stringent ransomware requirements, third-party tools often offer deeper immutability and air-gapped architectures. The honest take is this: if your workloads are primarily in Azure, start with Azure Backup. It's simple, cost-effective, and deeply integrated. If your environment is complex, multi-cloud, heavy on-prem, or requiring advanced DR, evaluate third-party tools. They cost more but deliver more in those scenarios. You've seen what it protects and how it works, but let's talk about the part nobody wants to discuss. What does it cost? The cost of Azure Backup. Let's talk money. Azure Backup uses a two-part pricing model, and it's pretty straightforward. You pay an instance fee for each protected resource, plus a storage cost for the vault itself. The instance fee scales with the size of what you're protecting. A small VM under 50 gigabytes, that's about $5 a month. A medium VM up to 500 gigabytes runs around $10. For databases like SQL Server, the per instance fee is higher, roughly $30 a month for a database under 500 gigabytes. Storage cost depends on how redundant you want your backups to be. Locally redundant storage, or LRS, is the cheapest option. Your backup data gets replicated 3 times inside a single data center. Geo-redundant storage, or GRS, replicates your data to a paired region in a different geographic location. That protects you if an entire Azure region goes down. It also costs about twice as much as LRS. Here's a real-world example. Say you have a 200 gigabyte VM with LRS storage. Your total cost, instance fee plus storage, runs roughly $15 to $20 per month. For a 10 VM environment, you're looking at about $150 to $250 a month. Compare that to buying a dedicated backup server, storage array, and software licenses, and suddenly the cloud option starts looking very reasonable. But there are ways to save money. Selective disk backup is a big one. If your VM has multiple disks but only 2 hold critical data, you can exclude the rest. Fewer disks backed up means lower instance fees and less storage consumed. Enhanced policy is another lever. Instead of taking daily full backups, you can use a policy that takes more frequent incremental backups and fewer full ones. The first backup is always full. After that, only changes are transferred. Over time, that dramatically reduces storage consumption. The archive tier is where long-term retention gets cheap. If you need to keep backups for years for compliance or regulatory reasons, moving older recovery points to the archive tier can be 10 times cheaper than keeping them in standard storage. The trade-off is slower restore times, but for data you almost never access, that's fine. Reserve capacity is available too. If you commit to a predictable volume of backup storage for 1 or 3 years, you can get up to a 40% discount compared to pay-as-you-go. The hidden risk is over-retention. It's easy to set a policy that keeps 7 years of daily backups for everything, but most of that data is never needed. You only need long retention for compliance data. Everything else can be trimmed. Review your policies regularly. If a workload changed from production to dev, adjust its retention. If a VM was decommissioned, remove its backup items. Every recovery point you don't need is money you're burning. Now that you know what it costs, let's talk about the biggest pitfall and how to avoid it. The biggest mistake: not testing your backups. Here's a hard truth that most organizations learn the hard way. The only good backup is one you've actually restored and validated. People get really good at backing up every day. They configure policies, they monitor jobs, they feel great when the dashboard shows all green check marks, but they almost never practice restoring, and that's where the disaster happens. When a real incident strikes, a corrupted database, a ransomware attack, an accidental deletion, you discover the truth. Maybe the backup was corrupt, maybe the wrong data was captured, maybe the restore process fails halfway through. You don't know until you try, and by then, production is down and the clock is ticking. Common pitfalls are surprisingly predictable. Restoring the entire server when you only needed the database. Restoring the VM but forgetting that applications need to be reconfigured afterward. Restoring to a different network and discovering the IP addresses don't match. These are the kind of problems that turn a recovery operation into a multi-day crisis. The fix is simple but uncomfortable. Schedule regular restore drills. Quarterly is a good cadence. Pick a test VM, restore it from backup, verify the data is intact, check that applications start properly, then delete it. The first time will take longer. The second time will be faster. By the third drill, your team will have a documented, repeatable process. Azure Backup makes this easier than it sounds. The instant restore feature lets you restore from a local snapshot almost immediately. You don't have to wait for data to come back from the vault. You can spin up a restored VM, verify it, and tear it down in under an hour. The takeaway is blunt but necessary. A backup strategy without a restore test is just an expensive hope. You're paying for protection you haven't confirmed works. Schedule your first drill this month, not next quarter, this month. Getting started. Your first 3 steps. You need to test your backup. But where do you begin? Let me walk you through 3 simple steps. Step 1. Figure out what you can't afford to lose. Your critical VMs, your databases, your file shares. Don't try to back up everything at once. Start with the workload that would hurt most if it disappeared. That's your top priority. Step 2. Create a recovery services vault. Think of it as a safe for your backups. Make sure you create it in the same region as your resources. That's the number one mistake people make. The vault ends up in the wrong region. If your VM runs in West Europe, your vault must be in West Europe too. Keep them together. Step 3. Set your backup policy. How often should backups run? Daily is standard. How long should you keep them? 30 to 90 days is a good starting point. What about redundancy? LRS keeps copies in one data center and saves money. GRS copies to a second region for extra safety. Once your policy is ready, enable backup on your first VM. Azure Backup installs the extension automatically. Start with one VM. Confirm the first backup completes. Then expand from there. Azure Backup Center gives you one dashboard to monitor everything. So that's Azure Backup. It's not just a backup tool. It's a safety net you set once and trust. You don't need tapes or servers, and you never have to wonder if it worked. You set your policy. You enable protection. You test your restore. Simple. Start with your most critical VM this week. That one step already puts you ahead of most organizations. Subscribe for more plain English cloud breakdowns.